and welcome everybody. I am Durgesh. I am the founder of WeLEAP Aerospace, and I'm also the president of MIT Researchers and Postdoc Association of Aeronautics and Astronautics, abbreviated as RPA Cube at MIT. And today we are having this outreach panel session where we have invited two MIT students and one MIT postdoc to share about their journey and their career path, how they navigated different milestones in their career, and also to talk about their research a little bit. So the session is meant to be highly it's an overview, but also it gives you some depth on how to navigate through the technical and soft skills required to have a good research career in aerospace. So first of all, today we have Dr. Rong Ma. She is a postdoc fellow. She's working at Computational Turbulence Group at MIT. She is working on developing LES models for simulations. And Miss Cadence Pine, I hope I'm pronouncing the name correctly. She is working on MIT Star Lab. She's also a GEM fellow. And last but not the least, we have Miss Palak Patel. She is at MIT Nest Lab, and she's also an STGRO fellow, and she's working on the field of producing oxygen and lunar steel in space. So today we will learn more about them and their work, and later on we will also have an audience Q&A session where you will get an opportunity to ask specific questions to all the panelists. So I'm sure this session is going to be very informative and kind of inspirational in a way. And one of the main highlights of today's session are also going to be the interdisciplinary nature of the research in this field. So we often think that, okay, I'm not interested in aerospace engineering, and maybe I cannot go in that field, but at the end it's a culmination of different fields of science and engineering, such as math and physics and material science, electrical and electronics communication technology, satellite communications, things like that. So you will discover more of that during the talk. So with that, without any further ado, I hand over to Rong. Rong, you can share your screen and share about yourself. And I'll stop sharing.
Okay. Yeah, hello everyone. My name is Rong Ma. I'm a postdoc from MIT Aeroastro. I'm very happy here today to share some of my research experiences from undergraduate to now. My education background, I did my undergraduate at Beihang University from Beijing, China. And then I went abroad for my PhD, and the PhD program is at University of Minnesota in the Department of Aerospace Engineering and Mechanics. And I joined the Computational Fluids Laboratory. And then from 2022, I joined MIT as a postdoctoral associate, and I joined the Department of Aeroastro and the Computational Turbulence Group. So then I will go through my research experiences from my undergraduate to my postdoc. So in my undergraduate study, that's the time I found my interest in fluid dynamics. I have done 2 research projects at that time and focused on experimental fluid mechanics. The 2 projects one is the wind tunnel experience, doing some study, like we have this pressure probe to measure the drag reduction in the pipes. And these pipes actually are manufacturing by myself. And I apply a certain wallpaper with the grooved roughness on it. And basically, we try to measure this drag reduction as the flow going through the pipe and how it works. And the other project is also conducted in the wind tunnel. It's about the particle image velocity measurements in a turbine cascade. So this experiment actually is harder than the previous one, and this one actually is a project that helped another PhD student to finish it. But during this procedure, I started finding my interest in fluid dynamics, and also I started to know how the research is conducted. Mhm. So I started learning like some basic research skills, like how we can do data acquisition, post-processing and analysis, and how we and also learn how to start writing a paper. And also from these experiences, I started to like apply for my PhD program. And for my PhD program, I find a position at Professor Krishna Mahesh Group at University of Minnesota. And from this, I started to decide to join a computational fluid group. So it's more like a transition from experiments to computation. And the reason I think it's really because this project I'm really interested. So about this project, it's a fundamental research about understanding how roughness affects the turbulent flows. And also it's through some high fidelity numerical simulations. So the motivation is about, and the background is basically like we have roughness everywhere in our life, in nature, and also in engineering applications. And this when we have the certain roughness on the surface, the roughness can modify the flow features. It can also change the flow from laminar flow to turbulent flow. As you know, laminar flow is uniform and regular, but turbulent flow is a chaotic dynamic system. It's very chaotic and statistical, so it's very hard to understand. And this project is actually about the roughness on the submarine. So like manufacturing or erosion or biofouling can really create this irregular roughness on the vessels, on the submarine surfaces, which can actually increase the drag and also increase the fuel consumption. So this is why this project is very important. So from this research, we can better understand how the roughness would affect the turbulence and how we can control the roughness topography so we can optimize this drag in this engineering problem. So from this research project, I think I really built my skills. Like I have like an insight and a better understanding on the fundamental physics about turbulent flows and also the roughness effects on fluid dynamics. And I also built up my skills on how to develop codes and solvers on parallel platforms because the high fidelity simulations, the code is actually a massively parallel code. So I really learned how to do high performance computing. And also during this procedure, I also have some teaching experiences. So that enhanced my teaching skills and also how we communicate with other collaborators. So that increases my computational communication skills and also increase my writing and presentation skills through those publications and conferences. So I really enjoy this research. And these are some other things I want to mention during my PhD journey. So as you can see, this is my advisor, Professor Krishna Mahesh. He's a very supportive guy and helped me and mentored me a lot during my PhD journey. And also another thing very important is I'm in a very diverse and very nice group. So you can see these are our group photos. We have our group social events, and this photo is like we went for a conference.
वर्क स्ट्रेस ज्यादा ले रहे हैं उस छुट्टियों पे को
Uh,
क्लियरली बोल देना
yeah, sorry.
बोलना तो है ही ना माने तो
Oh yeah. So and this photo, we went
That's what I'm
to
saying.
a conference APS, and this is the photo from the conference. So I'm really grateful and feel lucky I'm in a very nice group because most of the time during my PhD, except that I talked to my advisor and got some guidance from him, they also helped me a lot. So I think that's also a very important factor for me to survive from my PhD. And also, I got a fellowship, which also encouraged me a lot. So this fellowship is from Zongta International Million Earhart Fellowship. So this fellowship is only for international students and for women students in aerospace. So I feel yeah, I really appreciate this this honor, and I feel I really got a lot of courages from this fellowship. Especially when that's the very hard time during the pandemic. I think this is really good for the underrepresented group as like women in aerospace. And here in this slide, there are several key points. I summarized what I learned to survive from my PhD. So I think the most important thing is we choose the right program and the right advisor and also the research group. So, and we have to be very passionate about our research because it's a PhD, it's a long time program. If you don't really like your research, you can't really continue and do it. So like I think it's important that we really care about what we are doing and we love it. And the third is to set clear goals and stay organized. So this is more related to the how we set the goals during our career paths. Like for me, I really want to do and stay in academia. So that's why I applied for a PhD program directly from my undergraduate. And now I am doing a postdoc here. And also, it's important to maintain a work-life balance. I think PhD students can still have work-life balance. It's very important for us, like for our mental health. So that's also quite important for us to really survive. Finally, but also the final thing is to build a support network, and this I'm mainly doing one thing is from our group members, and then it's the people in our department. We can get a lot of support from them, and also from the conference. There we can meet many people in our field, and that's very useful for us to build a network there. So when we try to find a job, and for me, like when I try to find a postdoc, I actually contacted Rajesh because she also graduated from Minnesota and we know each other for several years. And when I tried to find a postdoc at MIT, I actually went to her and talked to her. So and I also got a lot of help from her. So this is how the networking help. And then I will go to like an introduction for my postdoc research now. So now my advisor is Professor Adrian Lozano-Duran, and I'm in a computational turbulence group. So again, I still focus on the surface roughness and the similar motivation, since the surface roughness has important effects on aerodynamic performance. But now it's about roughness on the turbine blade. So actually, they are all the same. I mean, they are all the same, similar application. But now the different things as transition from high fidelity simulation and try to understand the fundamental physics to develop models, more focus on like how we can develop models to model the roughness effects. So these are the two computational tools I use in my postdoc research. One is DNS simulation, which I also have done a lot from my PhD. So this simulation can provide full flow data and it resolves all scales of motions. These are the advantages, but the disadvantages is it's very expensive and impractical for engineering application. And the other computational tool is wall-modeled large eddy simulation. So for this simulation, it resolves large scale, but models small scales. So from this, they can actually save a lot of computational costs. And it's more feasible for flows in engineering applications. So as we can see, the wall model LES actually has the potential to for us to simulate flow with roughness, because roughness, there are many roughness scales we need to resolve, and also flow the small scales in the fluid. But by using wall model, we can actually model the roughness effects, and in this case, we can save the computational cost, and also we can get our results or the simulation we want to conduct it in the real applications. So in my project now, our goal is to bridge the physics and state-of-art machine learning techniques to develop turbulence modeling. So the first step I have done is we created a roughness turbulence database by using direct numerical simulation. Like these are the rough surfaces I generated to mimic the realistic rough surfaces. And then this is one animation I'm showing here, are the turbulent channel flow we are conducted. And so from this, we actually create our own roughness turbulent database, because we really need this from the high fidelity simulation and use this data to develop the wall models. And the second step is to develop the machine learning wall models for large eddy simulation that accounts for roughness. Like here is, we use the neural network, and these are how the wall model works. So basically, we have our fluid properties like velocity plus the roughness features. And we give it as the input as the machine learning wall model, and as the output is the wall shear stress, which we give back to the boundary condition of the simulation. And from this, we can actually predict the drag for graph cases at different Reynolds number within an error of 7%. So these are the project I'm doing now. So from this project, I also want to summarize the skills I'm continue build up. So as we can see now, I learn more like how machine learning techniques and also uncertainty quantification can be applied to computational fluid dynamics. So it's more like interdisciplinary nature for the research. So which I really love a lot. And also, I'm also mentoring students, graduate students, and also started like writing some proposals during my postdoc. And these are some skills I kind of accumulate and from my currently postdoc position. And I think that's it. I would be very happy if you have any questions. Thank you.
Thank you, Rong. That was a nice summary. You have done a lot of work and you presented it nicely. And thank you for highlighting the need of like networking and all the other important stuff, the transferable skills and all. Okay, so next let's go to Palak.